Okay, so now we're looking at balancing equations quest. The introduction questions are kind of a review of what we've previously done. So we're going to write the equation for the reaction of sodium and chlorine to form sodium chloride. I'm not going to write this out. I'm going to type this out as opposed to write it out uh, to save time. So sodium, Na, plus Cl. Now this is going to be a subscript 2, right? So it's Cl2, and it's going to be arrow, and it's going to make sodium chloride, NaCl. And then the equation for calcium nitride and sodium chloride, so double replacement. So calcium nitride is Ca 3N2 plus sodium chloride, NaCl, to make calcium chloride, CaCl2, plus sodium nitride, which is Na3N, and that's the stuff that we did previously. And you should do that. Now, these numbers, a subscript is the small number, and so when we looked at calcium chloride, it should be CaCl2. The 2 tells us there are 2 chlorides, right? And that's a subscript. That's those small numbers. A coefficient is a number that goes out in front. And 3, like 3 H2Os, tells us that there are 3 total waters, which means there are 6 hydrogen and 3 oxygen, because 3 times 2 is 6, 3 times 1 is 3. So 6 and 3. So let's practice counting, okay? So let's say we have this here, and we see 4 Ca3PO4 2. We want to know how many oxygen atoms. So the first step is I take 2 times 4 to get 8. What the 4 in front means there's 4 times 8, so there's 32 total. So let's look here. How many oxygen atoms are each of the following? Well, just here, that 3 tells me there's 3. Here, there's a 1, but there's a 3 in front. So 3 times 1, 3. I look here, I got 4 with the 4 in front, so 4 times 4, 16. And then I look here, the 2 with the 3 means 6. With that 5 in front, 6 times 5, 30. So now, let's look at sodium and chlorine to make sodium chloride like we did above. Chlorine by itself is diatomic, Cl2, but what we know is that we don't have equal amounts on each side. So to balance, we go back and forth and we count, and I have some examples that I'll do in a second here of how to do it. But essentially, you're putting a 2 here. When you put that 2 here, that means you got 2 Cls. But it also means you got 2 NAs. So I have 2 NAs on this side, but only 1 on this side. So then I just put a 2 in front to get 2 NAs, and now I have 2 Cls, and now I'm a balanced equation. Calcium nitrate, or calcium nitride, sodium chloride to get calcium chloride and sodium nitride. So we count everything, and this shows you the steps on how to balance. The big thing about balancing is that we balance using coefficients, okay? Using coefficients, not subscripts. We never change the subscripts, only the numbers in front. So let's take a look and see if we can see if they're properly and completely balanced. So here, I got 2 NaCl, so 2 NAs, 2 Cls, and 1 Cu. Here I have 1 Cu, so that's good. 2 Cls, that's good, but 1 Na. Not good. So this one is no good. Here I have 3 Cs, 3 Cs. 8 H's, don't have 8 H's, so that's not balanced. 1 Mg, 1 Mg, 2 Cls, 2 Cls, 2 F2s, 2 F2s. So that one's okay. Now let's look here. 1 Fe, 2 Fes is not. So C is the only one that's balanced. All right, so number 6, we're going to balance each of these, and I'll walk through the steps on how to do that. Do it now. All right, so we're number 6, A, and we're going to balance this equation. Again, we count Ca, 1, Cl, 2, Li, 2, and O, 1. On this side, Ca, 1, Cl, 1, Li, 1, O, 1. So now look at my numbers. The Li and the Cl have 2, only 1 here, so if I put a 2 in front, that gives me 2 Lis, 2 Cls. And I'm balanced. So that's how I balance letter A. Okay, look at letter B. B, I got aluminum sulfide plus copper makes copper 2 sulfide plus Al. Nice single replacement reaction. So then I count Al, 2, S3, Cu, 1. On this side, Al, 1, S, 1, Cu, 1. All right, so I can pick whatever I want to start with the balance. I'll balance the Als first. 2 here, 1 here, so I'll put a 2 right here. They're balanced. My S's, 3 on this side, 1 on this side. So to balance my S's, I put a 3 here. Now when I do that, I do get 3 S's, but I also get 3 Cus. So now my Cus are unbalanced. I got 3 here, 1 here. I put a 3 here, and that balances my Cu. So it's 1, 3, 3, 2, and it's balanced. And now 6C is sodium phosphide plus magnesium bromide makes magnesium phosphide and sodium bromide. So then we count Na, 3, 1P, 1 Mg, 2 Brs. I look here, 1 Na, 2 Ps, 3 Mgs, and 2 Brs. So to balance, I'll start with my NAs. I'll put a 3 here. That gives me 3 Na. This should only be a 1. I'm sorry, it should be 1 Br. I put a 3 here. That gives me 3. Okay? So I have 3 Mgs here. My Ps, I got 2 and 1. So I put a 2 here. I put a 2 here. This gets me to 6. And that gets me to 2. I'm at 2 here. But now my NAs are messed up. So how do I get 6 here? Well, I erased that 3, and I put a 6, 6 Na, 6 Br. NAs and Ps, my 3s, or my Mgs are 3 and 1, so I put a 3 here. Gives me 3 Mgs, and in the process I got 3 Br2s, which is 6 Brs, 6 Brs. Now I'm balanced. 2, 3, 1, 6. And that is number 6 on this assignment. Here are your answers to question 6. And again, I balanced them, but you can double check. If it's a polyatomic ion, you can read through this, but understand that if it's a polyatomic ion, you keep them together. If it's on both sides, so like SO4 here, SO4 here, when I do my count, I keep them together. PO4, PO4, I keep them together. And I'll show you again examples on how to do that. Number 8, let's see if they're properly balanced. 1Ba, 1Ba, 2 NO3s, 2 NO3s, 2 F2s, 2 F2s, 1 SO4, 1 SO4. A is balanced. Let's look at B. 3 SRs, 3 SRs, 2 CLs times 3, 6 CLs, not only 3 on this side, so it's not balanced. 3 CAs, 3 CAs, 2 PO4s, 2 PO4s, 6 NAs, 6 NAs, 2 CO, or 3 CO3s, 3 CO3s. So C is balanced. And then D, 1 Fe, 1 Fe, 2 NO3s, 2 NO3s, 1 Mg, 1 Mg. D also is completely balanced. And I'll walk through the steps on how to do that. Doing number 9, do it now. All right, so now we're looking at number 9. Number 9, we do our count. CA, I have 1. Now I keep the NO3 all together. And I got 2, and I do that because I have NO3 here and NO3 here. And then my Na is 1. CA, 1. Again, NO3s all together. There's 1 NO3, and then there's 1 Na. So to balance, I got to balance my NO3s. I put a 2 here. While that balances my NO3s, it also gives me 2 NAs. My NAs are not balanced. I put a 2 here, and now I'm balanced. 1, 2, 2, 1. Now let's look at letter B, aluminum carbonate. Plus magnesium chloride makes aluminum chloride and magnesium carbonate. Getting the balance, Al. 2, CO3 here, CO3 here, so I can do 3 carbonates, 1 Mg, 2 Cls. On this side, 1 Al, 1 CO3, 1 Mg, 3 Cls. So my ALs aren't balanced, so I go ALs first. I'll put a 2 here. Gives me 2 ALs and 6 CLs. My CO3s, I got 3 on this side, 1 on this side, so I want to put a 3 here, right? It gives me 3 carbonates, but it also gives me 3 magnesiums. Now my magnesiums are 3 and 1. I put a 3 here. In doing so, that gives me 6 CLs, which works out. So here I'm balanced. 1, 3, 2, 3 is balancing that one. And then letter C of number 9 is barium phosphate. And sodium carbonate. And we're going to have the sodium phosphate first. And barium carbonate second. All right, so let's add them up. Ba is 3, PO4 is here, in here, so I can keep it together. That's 2. Na, 2, CO3, 1. On this side, Ba is 1, PO4 is 1, and A is 3, CO3 is 1. So my BAs first, I put a 3 here. Gives me 3 BAs and 3 CO3s. My PO4s, I got 2 and 1, so I put a 2 here. Gives me 2 POs, but it also gives me 6 NAs. So now I got to balance my NAs and CO3s. I need 6 NAs, so I put a 3 here. It gives me 6 NAs, but it also gives me 3 CO3s. And I'm balanced, and this is number 9. And then there's your check. But again, you can see the work I did. And then number 11 is for what you to do for the assignment. Complete and balance the following equations. At the end of this video, I will have a link to the correct answers so that you can check yourself. You can also check yourself in class. But either have me check it or check it off the doc. Thank you.